So this video refers to Lecture 3, free body diagrams, and specifically beginning at slide 13, the first example, which has a box of 550 newtons and two ropes A, B and AC holding it. We're asked to draw a free body diagram and then solve the equations of equilibrium for the forces in ropes A, B and AC. So the first thing we'll do is draw a free body diagram, so I'll draw that. We've got point A, we've got a force FC, we know the ratio that's moving in the two dimensions. We've got a force B, which is at 30 degrees to the horizontal. And then we've got a weight acting downwards, and we know that's equal to 550 newtons. So that's our free body diagram for this question. So we'd then say the sum of the forces in our x direction and the sum of the forces in the y. I'll start with the x. We're going to have the x component of force B, so this bit here, and that's acting negatively because it's backwards, so minus FB cos 30. We're going to have plus 4/5 of FC, and that has to equal 0. And then the sum of the forces in the y direction, we're going to have minus 550, because the 550 is acting downwards. We're going to have a component of FB and FC acting upwards. So we'll call that plus 3/5, should be a 3, sorry. It's terrible writing. Plus FB 30, that should be a 30, that angle. We can then rearrange these equations. We can solve them simultaneously. As you start to do more of these problems, you'll realise simultaneous equations are quite important to be able to solve these. So I'll work through this one with you. If we rearrange the top equation, then we can get either FB in terms of FC or FC in terms of FB, doesn't really matter which. I'll get everything in terms of FC. So FC, this is rearranging the top equation, equals FB cos 30 times 5 and divided by 4. I can then substitute that into this equation instead of FC. So if I just pause this and then clear my board and rewrite what I know. So I've just made some room at the top of the board there to substitute that new value for FC. So we're going to have 3/5 of FB cos 30 over 4 times 5 plus FB sin 30 equals 550. So I can then take FB out as a factor. I can rearrange that. So I'd have FB brackets 3/5 times, I'll write it here, FB 3/5 times 4 cos 30 to the bracket plus sin 30 equals 550. Should be a B, I apologise. So I'll then take my everything apart from the FB and divide 550 by it. FB will then equal 478 newtons. And if I substitute that into either of my other equations, FC will come out at 518 newtons. So that's the first example out, first 2D example out of lecture 2. If you now pause it here and then have a go at the group problem solving exercise, and then if you play it again I'll show you how to solve that. Okay, so the group problem solving exercise that you should just have been doing is about a 20 kilogram lamp being held. There was a series of cables, and there was at point A, B, C, D and E. And the first thing the plan suggests is to draw a free body diagram just for point D. You're actually going to have to do two small free body diagrams and solve two sets of equations to finish this, so it's slightly harder than the first example. So for point D, we're going to have force DE, and that's moving at 30 degrees to the horizontal. We're going to have the weight of the lamp, which is 20 kilos times 9.81. We're going to have force CD, and that's completely in the horizontal. We can then say our sum of the forces, and we'll start with the y direction because we have a known force, because we know the weight, equals FDE sine 30 minus, and 20 times 9.81, I haven't got the answer for, hold on, it's 196.2. That all equals 0. So I can then rearrange that to find FDE. So FDE is 196.2 divided by sine 30, which is 392. And then my sum of my forces in the in the x direction. The x direction is going to be FDE cos 30 minus FCD. I can substitute my 392 in, so 392 cos 30, move my CD to the other side, so it equals FCD, that equals 340 newtons. So that's the first step done. So if I then look at point C, again there are three forces, FCD, FAC, we know that's a 3-4-5 triangle, and FBC, and we know that's 45 degrees there, which means that there's a series of 45 degree angles there, including just that's also 45. That might help you to see how to solve this. That's you may have learnt that's alternate angles or Z angles at GCSE or A level. So then I can do my sum of the forces of my x and y. I know what FCD is because I've worked it out on the previous page. If we think about point CD, if the force is acting that way at point D, it has to act that way at point C because it's going to be a constant tension throughout the whole cable. You can't pull on one end and push on the end it push the other, or you have to pull on both ends to have tension. So my sum of my forces in the x direction equals 340, which we worked out earlier, minus 3/5 of FAC minus minus FBC sine 45. And that will all equal 0. And my sum of my forces in the y direction will equal 4/5 of FAC minus FBC cosine 45, and that will also all equal 0. And then what I can do is I can solve those simultaneously. Now for this one it's slightly easier because I know that sine 45 it's the same as cosine 45, so I can say that 4/5 of FAC equals FBC cosine 45, just rearranging some of the forces in the y direction. I can substitute that in because I can say that that's the same as FBC sine 45. Substitute that in up here. Rewrite the sum of the forces in the x to be 340 minus 3/5 of FAC minus 4/5 of FAC, so minus 7/5 total. So FAC is going to be 340 times 5/7, which equals 242.9, so the PowerPoint of the lecture says 243. They've rounded it, that's fine. If I substitute that value back in to either equation, then FBC, I think I'm going to run out of room down here, FBC comes out at 275 newtons. So that's both of the examples from Lecture 3, free body diagrams. That was both the two-dimensional examples that we've considered. If you watch the next video on free body diagrams, we'll look at some 3D examples.